Hello, welcome to HandLab Chapter 1, Video 5. This video will introduce you to the Polhemus Liberty, a modern piece of equipment for recording position data in the lab. The Liberty has up to 16 channels, each one of which can record at 240 times a second. Let's take a look. Turn it on at the bottom left. The data is sent to your computer via a high-speed USB cable, or you can use the old RS-232 port. At the top left, the large cable goes to the magnetic transmitter. You can have up to 16 receivers, with 4 receivers for each of these 4 cards that fit into the back of the machine. The 17 long cables are all arranged very neatly across the lab and onto the experimental table. Compared to the fast track, there's a larger, stronger transmitter that sits just behind the experimental area. And just like the fast track, it's very sensitive to metal, so keep all metal away. And that includes the receiver cables. If they get too close, say less than 15 centimeters to the transmitter, they start to interfere. Each of the P-sized trackers can be attached to different body parts or objects, and having 16 trackers means we can be more flexible and rearrange the trackers more quickly between experiments. Just in case you didn't hear me the first 3 times, there should be no metal or large metal objects near your experiment, at least a meter away. And we've even removed the screws and re-glued this wooden table back together, as the screws inside the wood distorted the data. Just like the fast track, the Liberty is very picky about the way and the order in which you turn things on. It's computer first, then the Polhemus, then the software. The biggest issue we have is computer updates. For example, Windows seems to disable USB drivers when updates are available or being downloaded. Do your updates regularly and definitely check before an experiment. When the computer's ready, turn on the Polhemus. It'll flash red for about 5 to 10 seconds. Wait until it stops flashing. Your computer may also notify you about USB drivers or software being installed. The PiMGR test program is the quickest way to check if the Liberty is running. Open it up and there's 1 plane per tracker. Each tracker gives you 3 position and 3 orientation data points 240 times per second. Position is X, that's left right, Y, front back, and Z, up down. Orientation is azimuth, imagine turning your head from left to right, elevation, looking up and down, and roll, imagine tilting your head onto your shoulder, like a little doggy listening to a new sound. To check it's working, start continuous streaming on the PiMGR program. Each plane should now move to a new location depending on where the trackers are. Move your trackers around and check that they move with you. Watch the planes move around too. Sound effects at this stage are entirely optional, but feel free to do your own. In the HandLab, we've been using LabVIEW to control our stimuli, and we can check that they're connected up using the NiMax Test program. Open the Devices and Interfaces menu and select the NI interface card. This program allows you to test all of the card inputs and outputs. We're going to use test panels. The interface card we use has analog inputs and outputs for vibrations, sounds, or muscle activity which vary continuously up to about 10 volts, as well as digital inputs and outputs, which is sending and receiving signals that are either on or off at about 5 volts. Within the digital input-output part of the card, there are 3 ports. Each port has 8 individual lines. Ports and lines are numbered starting from 0, so the first line is port 0, line 0. Each line can be set as either input or output, and at any one time it can be low, off, or high, on. Set up your signals and then press Start, which sends the signals to the card. To test the stimuli, turn all the lines in ports 1 and 2 on. If everything's working, the stimulus lights should come on. Finally, we're ready to run an experiment. Open LabVIEW. LabVIEW is a massive program for running all kinds of equipment. It's very flexible, it's an entire software programming language, as well as having numerous functions to connect with hundreds or thousands of different bits of equipment. We've written some code to run this experiment. In the HandLab, you'll always have a project number, experiment number, subject number, and the HandLab anonymization number. Put all those numbers in and make sure they're non-zero so the experiment can work. In this experiment we have 3 different gloves, small, medium and large, and this determines which of the 16 trackers are used. We're going to do a practice, so make sure the practice light is green. You start the LabVIEW program by clicking the white Run arrow at the top left. Then click Start Block, and in a few seconds a new file name will appear based on the selections you've made in the boxes above. At this point you check your participant is ready and set the starting position of the hand. When they're ready, press Record Hand Position. In our experience, this is the most common point for the experiment to fail. If nothing happens, then it's some sort of software or driver issue, so restart the software completely, or you can restart both Polhemus and the software, taking care to do it in the same order, nice and slow. In this experiment, the task is to reach towards the illuminated table tennis ball. If the illumination changes as you are reaching, then you need to reach to the new location. The task is to update your reaching movement as quickly as possible. The Liberty is streaming data from all 16 channels to LabVIEW in real time. On half of the trials, when the velocity of the hand exceeds 15 centimeters towards the initial target location, LabVIEW detects this and switches the illumination to a different location.